Hello and welcome to this channel. My name is Naveen and I'll be a host. Today's topic is containerization, and to explain the concepts, we will use an example of how application deployments have changed and the evolution of it. So let's begin. Well, from the agenda standpoint, we will start with containers, the relevance of it, followed by the application deployment, the evolution, starting with the physical machines, hypervisors, containers, and then we will do a summary. So let's go ahead with the setting the context on the relevance itself. Now for that, you need to question one thing. IT industry is full of buzzwords. Is containerization also a buzzword? Now, to qualify this and to know whether or not it is relevant in today's industry, you can validate it in multiple ways. One that you can do automatically by yourself, looking at the market trend. This is something you can log into LinkedIn and look at the most desired jobs and the job profile and any of the careers that are happening at very innovative companies. You'll most likely see the word containers. Sometimes you may not see the word container or containerization, but you would see things like a Docker container, container orchestration, container management, Kubernetes, or K8s. No matter what we're looking at, essentially it follows the bottom line of utilizing containerization as your foundational unit. The second thing is you can also look from a scenario standpoint. Let's say you're at a technical conference and having a conversation with some of the folks who attend there. And when you strike the conversation on what they are doing for innovation in their company, what is it they are doing to deliver value to their business faster, the chances are all these different words which we spoke about, they will be part of your conversation. And reality standpoint, if you do a ground check and the field check of what actually is happening, things have changed from your modern application architectural choices. Because we are no more talking about a single monolith-based architectures. We have cloud-native architectures, microservices style, event-driven architectures, serverless. No matter which angle you look at, the foundational unit is always going to be containers and containerization. So you can see how this topic is so relevant in today's industry and so current. So you might question, if this is current, is this going to sustain? Now for that, the container adoption itself is only going to increase even more than what we actually have today. So you're investing in a technology, and learning this technology is only going to benefit you not only today, but also in the long run as well. Now, setting this particular context, let's go ahead and see what is the next step on understanding the containerization itself. So we will start with the application deployments, and for this, we will take about 25 to 30 year time frame as to what was happening in the application deployment space. We started with the physical machines. So physical machines, physical servers, these are your, take your HPs or, the Intels, whatnot, right? So you can have a Dell machine that is coming in. So essentially we brought this physical server, have an operating system, and whenever you wanted to deploy an application on top of it, you took the application and everything that your application needs in terms of binaries and libraries and whatnot, you take that, move it into this physical server one. Now, if you want to take and deploy another application, say application 2, you would actually take a physical server 2 and then your application number 2 coming in here. Rinse and repeat, you have application 3, physical server 3. You can see how this pattern is actually changing as you go forward. Now you have to question, why did we do this? That is where a lot of our learning would come into picture. So there is always an advantage. There is always a benefit in doing an application deployment and having this particular pattern. So what are the benefits that we're going to get out of this specific deployment architecture? The first thing you would notice is there is a clear separation of concerns. In fact, this is a very strong principle in all the software industry. Now, separation of concern comes in two different formats. You have a physical separation, or it's a physical isolation, and then you will have process isolation. So if you see how your applications are isolated from a hardware level standpoint, each application has their own physical server, like the application 1 on physical server 1, application 2 on physical server 2, and so on and so forth. Process isolation is coming again purely because each application has its own physical server. So at any given point of time, you will have application 1 using only the resources present in the physical server 1 itself. That brings us to our second point, which is each application has its own dedicated resources. Talk about CPU, talk about memory. You can also extend this to the storage that is available on that particular machine and whatnot. So while there are benefits, there is always a trade-off in having any kind of technology, any kind of architecture that you have. So what is this trade-off, or what is the challenge that you would encounter? Let's try to question those very specific aspects and see what we have in store. The first and the foremost thing you would start noticing is if you want to onboard a new application, say application 4, you would need a physical server 4, which means you have to go through the traditional way of getting a physical server. So you have to go through procurement. They place an order with the HP or Dell. Then the machine actually comes all the way into your data center. Then you hook up that the machine into the data center, give it an IP, have security context around it. Then you have your application that can be deployed on top of it. So you can see it's a very lengthy process for you to even onboard a single application. That is not something which is desired across any industry whatsoever, but that's exactly how we did many, many years ago. And it's also inefficient usage of resources. Now for this, let's take an example of physical server 1, 2, and 3. Let's say they are having the same capacity from CPU and memory standpoint. And if your application 1 is utilizing only 20% of this, same is the case with the application 2 utilizing 20%, and application 3 is also utilizing 20% of physical server 3, what we are talking about is effectively across these 3 different servers, 20% utilization is what is used. However, the 80% is still unused. Even though you're trying to onboard a newer application, you cannot leverage the 80% unused capacity. So efficiency-wise, it's not really an efficient solution whatsoever. What it means is at the end of the day, it means the cost of the hardware. It is going to roll down into your financials. So the cost of the hardware is only going to increase as we increase the number of applications. And next point is also complexity in operations. We are just talking 3 different applications. When you put an enterprise context, you will have hundreds of applications. Now, hundreds of applications, hundreds of servers, and when you put high availability fault tolerance in it, you're talking many, many different servers. So how do you manage such kind of complexity? In fact, that also adds into the cost of what you actually have. So we can see there are benefits in this particular deployment architecture. However, there are also challenges that we introduced. And all these challenges is which makes us think even more and bring out a newer technology. And to solve these very specific problems, we came up with what we call as hypervisors. And that's how they were introduced. Let's try to see how hypervisors solve some of the problems and challenges which we talked in the physical machines era. So for that, we need to understand what a hypervisor is to begin with. So we have very similar to, this is your physical server deployments. So the hypervisors, you have the same physical server. There's nothing changing in that layer. We are having an operating system on top of the physical server. Now, just note that this is called as a host operating system. We will get to that in a moment. But for now, think of it as an operating system on top of the physical server. Then you have this hypervisor. This is a software layer. The software layer of the hypervisor can sit straight onto the physical server. It can also sit on top of the operating system. For now, let's go with sitting on top of the operating system. So what this software layer does is it can take the physical machine and it can carve out logical units of that particular physical machine. Or say you can have the physical machine broken down into 3 logical or virtual machines called VM1, VM2, and VM3. Now, because these are independent machines, they also need to have an operating system. And that's where we call that as a guest operating system. Now you start to make sense as to why it's called as a host, because this is hosting everything. The guest is purely because it is a guest guest on top of this particular physical machine itself. So we talked about 3 applications. Now we can take these 3 applications and put these applications on top of this VM. So you have VM1, application 1, VM2, application 2, and so on and so forth. So you can see things have changed a little bit, and let's go ahead and see what kind of benefits do we have, at the same time how the challenges were addressed. So first and the foremost thing, we talked about separation of concerns. We always said it's a hardware level isolation is important. There is also process level isolation that is also important. Now, if you see your application 1, you have VM, and VMs have their own dedicated amount of CPU and the memory. So from a hardware standpoint, they are still isolated. Application 1 cannot understand what is going on the VM2 or the application 2 because they're completely isolated to begin with. And the process isolation is also coming from the fact that each of these applications have their own VMs. So there is nothing which we have lost going into the hypervisors world. The second is the dedicated amount of resources. So while there was only, in the example we talked about application 1 utilizing 20%, you can carve out these VMs based on the usage that is required. Say VM1, you can allocate a certain CPU and the memory, and that is available for the application deployed on it. So you can see we are still having a dedicated amount of resources per application. But what essentially we did is we reduced the challenge of onboarding in your applications. Purely because now you have physical server already, and if there is unused capacity, you take that unused capacity and you spin a VM using the hypervisor. Spinning a VM is not going to take as long as getting a new physical server to begin with. We are talking 10 minutes or even less whenever you want a new VM that needs to be created based on the capacity that you have. So your onboarding of applications is much, much quicker. The next one is better utilization of resources, because your physical server, any unused capacity, you can create a VM and have an application onboarded. Now you're able to utilize the resources better than what we were doing in the previous case. This is also a very improved cost model, purely because you are utilizing the unused capacity, and complexity of the operations is also reduced. Is because you don't need to have one physical server per application, and when you put enterprise context in it, having hundreds of servers, instead of that you have VMs that you need to manage to begin with. But again, technology evolved, but the newer technology gives us some new challenges, and let's try to see what these challenges are. And you have to question this all the time, every time there is something new that is coming into the market. The first and the foremost thing is we have 2 different operating systems. One is the operating system that is sitting on top of the physical server. The second is there is also a guest operating system for each of these virtual machines. And this is not a small operating system, right? This is a full-blown operating system, so it's going to consume resources. While we did justice in terms of making sure resources are better utilized, if OS is taking a lot of amount of memory or CPU, that is not adding any value to the application. So in a way, it is not really that efficient, but it is definitely efficient when compared to the physical servers we talked about earlier. Then you also need operations. While the number of physical servers and the maintenance of the physical servers is reduced, the complexity increased because now we introduced a guest operating system in terms of the VMs. Whenever we have our operating system, you have to go through the entire life cycle. So not just installation, you're talking about upgrades, you're talking about patches, you're talking about security updates, whatnot. So you are increasing the complexity in some way or the other to the operations team in this particular hypervisor model as well. Now, when compared to the previous model, where if you have a physical server and you just need to start your application, you can start so easily. But at the same time, if you have to start within the context of a VM, it does take a lot more time, because an application is hosted on top of a VM. So if you want to start, say, an application 3, first and the foremost thing that you need to do is bring up the VM instance, and then you have your application process that is being started. So as you can see, while we addressed some issues we had in the physical servers, we also introduced some of the challenges to begin with. So one of the things that we can actually think is, well, why do I have to have one application per VM? Why can't I have more than one application deployed on the VM so I can reduce the operations complexity that is involved? And at the same time, we can also do a better utilization of resources. Now, this is a pattern that I have seen in many customers as well. And let's try to play this and see what it actually means and what you should be aware of. And you should be questioning a couple of things as well. So what we are saying is, if you take a VM3 and you have an application 3 and your binaries, instead of just having application 3, what we're going to do is we'll use application 3 and libraries, but we'll also introduce application 4. Now you can extend this to many applications, but for the sake of our discussion, we'll take only 2 applications deployed on VM. Now, whenever you have more than one application being deployed, there are very highly likely chances that there is something which is common between these applications. If you take within the context of a Java world, we are talking about the Java runtimes, or sometimes even the SSL libraries, whatnot. So what we would introduce is a concept called as a shared library that is common between your application 3 and application 4. If you have seen this architecture in your career, if you have been in the IT industry for some time, you would know a couple of things, and those are called blaming wars. This is where one team blames the other team, or one person blames the other person. When you have such kind of deployment architecture. And let's try to see what type of things we actually hear in the IT industry. Number one, you would hear things like, it works on my machine, I don't know what's happening on the server. Let's try to see why this happens, right? So if you take application 3, it is on, say, version 1.0, and you have application 4 that is also on 1.0. Let's say application 4 is going ahead with modernizing their version from 1.0 to 1.1. And as a part of that modernization or enhancement, their shared library, let's say, it gets upgraded as well. Now, these application teams typically don't necessarily talk to each other. They are siloed in their own ways. So when application 4 deploys the version 1.1, they also update the shared library. But the application 3 and the team is unaware of this particular update. So what happens is this runs into an issue. So when the higher management talks about, can you replicate that issue on your local machine to see if it is actually the case, when you run on the local machine, you don't see that issue, purely because on your local machine, you don't have application 4, which had modified the shared library. You can see why this happens. This is a very common problem that happens across the board. While VMs give you some access, you may run into this problem if you are dedicating more than one application on the VM. The second thing which you will also hear is we are impacted because of the other team or the other application. And this reason why this also happens is in this particular deployment model is if you have application 3 and 4 deployed on the same VM, technically both these applications have access to all resources on this VM number 3. So if your application 4 has requested more CPU power or is a more amount of memory from the operating system, it provides to this particular application. Now, while that is happening, it will keep this machine very, very busy, which means your application 3, when it has to process some requests, it may not be able to process because the machine becomes so busy serving application 4, your 3 goes into a different mode. And that's where the impact is felt in this particular case. And that's the reason why we keep hearing things like impacting because the other team has created a problem for us. So you can see whenever we are dealing with resource sharing, it becomes a problem. Whenever we are dealing with libraries being shared, it becomes a problem. And that is where we always talk about separation of concerns being a very, very important terminology and important characteristics whenever you're talking about whatever is your deployment. So keep that in mind when you're dealing with it as one of the lessons learned from the IT industry. Now, one of the other questions you might be having is, well, hypervisors, I've been hearing and I never heard of the hypervisor. If you are an end user, most likely you would have not seen, purely because when you access a machine, you don't really have a clear way to say whether it is a physical machine versus a VM. Unless you're a sysadmin, you can actually run some commands to understand it. But If you're understanding what are the different market players in the hypervisors world, uh, this is a set, but again, by no means this is comprehensive. This is just for your understanding on the hypervisor technology that is there. VMware has got quite a different options available. You have Oracle. From a Linux standpoint, KVM is the one. Microsoft is Hyper-V. A lot of us might have seen the Oracle VirtualBox and kind of experimented with it. But at the end of the day, all of these are trying to do the hypervisor or say create VMs on your machines and being able to experiment what you need to do. Now let's go ahead and see. There are challenges that got introduced with hypervisors, and there are some design considerations we talked about. How does containerization solve all these problems? And why is this technology taken so much into the current world? So for that, we'll start with the hypervisor where we ended. What we're going to do is that we have the same infrastructure here, and you have the operating system. And one thing which you start to immediately notice is there is no concept of host operating system and a guest operating system. We're just calling it as an operating system. Now, to understand containerization, we need to understand what this container engine is. At the end of the day, think of container engine as a software that is able to take a package and run the process that is packaged in that. So essentially, this is a software that is going to run your containers. And we'll get to this in a moment as to what these boxes would mean. That is the immediate thing that you would also notice between the previous one and this one. With this particular technology, let's go ahead and see what were the challenges we faced and how we were addressing those challenges with this. The first and the foremost thing is when we talk about it, again, separation of concerns. Two things are happening. There is a physical level as well as a process level isolation. Containerization is purely driven from a process level isolation, but there is few things that you can actually talk about in the hardware level as well. So from a process level isolation standpoint, there is a concept called namespaces. Namespaces comes from the fact from a Linux machines standpoint. What it does is if you take a process, you can assign a specific namespace to that particular processes. So you can take this application 1, assign a namespace, same is the case with application 2 and 3. When you do so, the applications cannot see anything outside of that particular namespace. So let's run that by an example, right? So if you have application 1 dedicated to say one namespace, it can only see within itself. It cannot see what is running outside of this particular namespace. Like it cannot see what's happening on the application 2 or application 3. And same is the case with the rest of the things. That way you achieve the process level isolation to begin with. The second thing we also have to understand is allocating resources and dedicating these resources, be it CPU or the memory and whatnot. And Linux comes with a concept called control groups. The control groups do two things. Number one is you can take your CPU and the memory and you can slice and dice that CPU into smaller chunks. And you can assign that smaller chunk to a process. So that way you can say this process only takes this amount of CPU or this amount of memory. The second thing it also does is it can restrict how much it is. So you cannot go beyond a certain value that is already dedicated to it. So if you have, say, a specific amount of resources dedicated to application 1, the process that is running can only utilize those resources. So you can see there is no way it can request way more than what it has been allocated to. And that solves a problem which we discussed a few slides ago, where dedicated resources are important and the other application cost an issue. You will never get into that situation as well. It requires little to no wait time for your application onboarding. This is purely because once you have the infrastructure and you have operating system and the container engine, essentially all it means is you just need to have your application container. You bring up the particular container and that is it. In fact, these applications do not even require an OS to begin with, purely because these applications can leverage the libraries. If there are operating system level or the kernel level libraries, they can actually leverage those within the application. That way, all it requires is package the application that you need and you run that particular instance and then you're good to go. It is also a best utilization of resources purely because you don't have multiple operating systems to begin with. You're not wasting resources on a guest OS and whatnot. Over here, all it runs is a hardware followed by you have an operating system, and that is it. It's also a very improved cost model, and you have very minimal complexity, again, because there is no guest operating system to begin with. There is no dependency management nightmares, and this is where we say in the VM world or the hypervisor world, when we talked about it works only on my machine, but I don't know what's actually happening on the server. Let's play that scenario. And in this particular example, I want to explain these boxes. So one thing which you're noticing is your application one and the binaries or libraries are in a box when compared to the previous deployment architectures. So when we talk about containers, you always think about the application code and all the dependencies that the application requires, you package them in that unit. So if you have application one and application two, this box will contain everything. In the previous case, when we talked about the shared libraries, those are non-existent in this, purely because the shared libraries will also be part of the same box itself. So if your application 1 is on version 1.0, application 2 is on version 1.0 as well. If application 2 goes into version 1.1 and updates that shared library, that is only for that application 2. It does not impact application 1 because from a packaging standpoint, application 1 has its own packaging to begin with. That's where you don't have to worry about how do you manage the dependencies between different applications. You worry about your application and nothing more. And lastly, you also have to understand that because these are very small footprint, they are much faster to start up because they don't require a complete operating system to even get instantiated, and they can easily scale. So you can replicate this much more easier when compared to the hypervisor world or the VM world. So you can see with this particular technology, there is a lot that has happened, and the reason why this is taken by storm is all these different benefits to begin with. So let's try to summarize what we have learned so far in this particular session. The first and the foremost thing is we said containerization is current, and it is going to stay the same for a very long time, which means if you're investing your time in understanding this technology, it is good for your career as well. Then containerization also provides a lot of different benefits. If you're coming from an infrastructure perspective or an application development, operations, and more importantly, your business as well. So there is a cost aspect, there is a easy access to the servers and whatnot that gives you beautiful advantages on all of this. Lastly, I want to leave you with this particular question is now that you understood some containerization piece, you want to go to the next level. In fact, you have to always ask this question, what you should do next and how you should level up from here. So until the next time, I would leave you with the questions in the next slide. So till then, I'll see you later and I will talk to you soon. With that, thank you very much and everyone have a good day.